Now, when things lose value over time, we say that they have depreciated. And depreciation is calculated in much the same way as we calculate compound interest. And the reason for that is that if you imagine something losing a percentage of its value, say throughout the year, then by the end of the year, whatever its value is, that will be the value at the start of the next year. And then it will lose a percentage of that, and then a percentage of that, and a percentage of that. And so we're taking that percentage always of the new value at the end of each time period in much the same way as we did with the compound interest formula. Now, the compound interest formula, we've seen this before already, looks a lot like the depreciation formula. You'll notice the only real difference is that instead of adding the rate to 1, and remember here we have to use the rate as a decimal, and we can use our calculator to convert a percentage into a decimal. The only real difference is that with compound interest we add the rate, and with depreciation we take it away. So let's have a look at an example here. We'll have a look at how to do it just by trial and error using our calculator, and then we'll use the formula to answer the same question. So my computer loses 25%, that's a quarter, of its value each year. Find its value after 6 years if it was worth $2,000 when it was new. Now, when you first look at this, you might be thinking, if it's losing a quarter of its value each year, surely after 4 years, it won't be worth anything at all. But in fact, because we are taking off a quarter of its value each year, and then a quarter of that, and a quarter of that, it takes much longer to depreciate using this sort of thinking. So let's get our calculators out. Follow along with me. Put $2,000 in. Now, if something's lost 25% of its value, how much of its value has it kept? 75%, right? So let's find what 75% of 2,000 is. We've put our 2,000 in. Let's multiply by 75%. Use the shift bracket button to get 2,000 times 75% equals. All right, now it's worth $1,500 and 1 year has passed. It's lost a quarter of its value. All right, if it's now worth $1,500, let's find 75% of that, and that will be the value at the end of the second year. So times 75% again. And your calculator should say ants for answer, times 75%. All right, now it's worth $1,125 at the end of the second year. Let's multiply that by 75%. So times 75% equals, at the end of the third year, $843.75. Just check you've got the same amount. Now let's multiply that by 75%. Now it's worth $632.81 to the nearest cent, and we've depreciated it now for 4 years. Let's keep going, 2 more. Multiply by 75% again. After 5 years, $474.61. We keep having to round off now. And one more time, times 75% equals $355.96 if we round that to the nearest cent. So $355.96 is what we got. Now, all we did there is we just multiplied by 75% 6 times, and whatever the answer was, that got multiplied again and again. Does that kind of make sense? Now let's use the formula and check that we get the same answer. So the total amount it would be worth, and remember these formulas give us the total amount that we'll have at the end. So we don't have to add or subtract anything. This formula really just spits out the answer. Now the principal is the amount that it was worth in the beginning. So in this case, that's $2,000. Then we multiply by 1 minus the rate. Now, R has to be the rate as a decimal. What is 25% as a decimal? If you're not sure, type in 25%. Now press the equals button, 0.25. So we've got 0.25 in there. Now, how many years or how many time periods did we have? 6. All right, let's type that exactly as we've written it into your calculator now. 2,000 bracket 1 minus 0.25, close bracket. And now to get the power up there to put the 6, we press that button that says x to the power of something, and it's got a little box up there. And that lets us put the 6 into the box, equals $355. Yep, and 96 cents. It says 957, but that would round to 96, wouldn't it? So you can see that for depreciation, you can use that method of just finding what the opposite of 25%, 75%. We found 75% of the number and we did it over and over again. But very handy to have a formula. After all, what if this was something that was depreciating for 100 time periods and we wouldn't want to keep counting it and doing it the slow way on our calculator? So we've got a quick method.